Hi, my name is Kenneth Anderson, and I am with the Ohio State University, and I'm updating you on our first year of data from the Clover project. This is done in conjunction with Debbie Holdren, Dave Gardner, and John Street. Here are the basics of what I will discuss in this update to our project. To start off with, let's give a little bit of background. We'll talk about experimental design, our current results, and future plans and where we could use some help. Starting off with background, in 2011 we won an $80,000 grant from the USDA, and the grant was to evaluate the use of Clover to reduce production costs on sod farms. One of the other benefits to potentially using Clover is this could be part of a value-added product for sod farms. Selling Clover in sod, it could be of interest to parks and recreation or homeowners or commercial enterprises that are trying to maintain their landscape. So to start off with experimental design, our research covers several dimensions. We are conducting studies on two types of grass, tall fescue and Kentucky bluegrass. They were evaluated under treatments involving clover and fertilizer. Microclover has a symbiotic relationship with rhizobium bacteria, which has the ability to fix nitrogen from the atmosphere and make it available for plant use. From what we understand, using nitrogen fertilizer shuts down the bacteria's atmospheric nitrogen-fixing capability. We wanted to test this out and see its impact. To get definitive data relative to our objectives, we are taking measurements on many different dimensions. How well and how long does it take for Clover to co-establish with each of the species of turf? How much nitrogen is found in the different soils? This will reveal how much rhizobium is producing. Color ratings are another rating reflective of nitrogen levels. Is the clover's presence impacting weed populations? And then measuring drought tolerance are shown in the soil moisture and soil temperature. We also did visual evaluations on the plots while going through the dry down period. Here are pictures of us establishing our research plots. The top photos were taken at Green Velvet Sod Farm. They were preparing the soil for our study. The bottom two pictures were taken of the research plots being established at OSU's turfgrass facility. I just wanted to mention that as we're doing this research, we want to mimic as closely as possible the practices of sod farms so that when it comes time for implementation or use of Clover, that it's as simple and easy to adopt as possible. Now for the data. First we're going to talk about Clover establishment. Along the bottom are the number of days after seeding. You can see we have been running this study for almost a year. Along the left we see Clover establishment. This chart shows data from Kentucky bluegrass. It took much longer for the Kentucky bluegrass to establish than we would have anticipated. The darkest color line represents the grass with the Clover. This one is of particular interest because this is the one that we want to watch. So watch for the darkest lines. That's going to be a key. Some common white clover has invaded the non-clover plots. We treated the clover to remove it from the study, as not to have it impact our study results. This graph shows the tall fescue and Clover co-establishment. The clover establishes quickly and then tall fescue kicked in quickly, out competing the Clover. The Clover's establishment strengthened as it matured. When we overlay the two graphs, you can see that the Kentucky bluegrass didn't compete as well as the establishment of the clover. I was personally shocked at how long it took for Kentucky bluegrass to establish, but this is probably more commonly known by sod producers. It also explains why the majority of the sod grown is Kentucky bluegrass, mainly because it takes so long to establish and is more challenging. We took soil samples and sent them to a lab for analysis. As you can see with the tall fescue plots, the Clover is doing the best at this time of measurement. There is no real difference between the top three treatments, which include the untreated tall fescue. We are unsure at this time why the tall fescue with the synthetic fertilizer has lower amounts of nitrogen. Probably as we do more testing, we'll see some of these results level out or change. Here is the Kentucky bluegrass. The microclover plots without fertilizer clearly have more nitrogen, while there is minimal difference between the fertilizer and the untreated plot. Now putting both graphs together, we see that the slow establishment of the Kentucky bluegrass does impact the amount of nitrogen in the soil. The tall fescue establishing faster most likely is making more efficient use of the available nitrogen. Here are the color ratings on tall fescue. The days after initiation are along the bottom, while the color quality is along the left. I want to once again point out the dark line represents the microclover. The untreated has the poorest color ratings as would be expected. I would rank the microclover in third. The microclover with fertilizer seems to be doing the best of all the treatments. The fertilized plot looks like it's also doing well. In the photos you can clearly see that the color of the microclover is not confusing the overall color rating, but the turf clearly has greened up. Here are the color ratings on Kentucky bluegrass. You can see that the microclover and the microclover plus fertilizer are the top two performing treatments. This complements the nitrogen data from the previous slides, with the Kentucky bluegrass fertilizer treatment not showing as well as the untreated. We believe that over time this will correct itself with what we know. When we overlay the data, we can see that the Kentucky bluegrass does get higher color ratings. There is also a dip on day 321 with the tall fescue and the Kentucky bluegrass that is probably due to dry conditions impacting the color ratings. Here are the tall fescue ratings based upon weed counts in the plots. The tall fescue already does a pretty good job of establishing, so the weed counts are overall low. With the Kentucky bluegrass, there is a correlation between establishment and weed counts. The microclover tends to crowd out other weeds. We wonder if there's the potential for a nurturing relationship between the microclover and the Kentucky bluegrass. We see that the weed count decreased over time as the Kentucky bluegrass continued to establish. When we overlay these graphs, we can see that the healthier the turf and the microclover, the fewer weeds present, especially with the Kentucky bluegrass. It'll be interesting to see what next year's data looks like. To understand the potential drought management capacity of the clover, we measured percent soil moisture. The dry down period started around day 292. Here is the data for the tall fescue, once again just pointing out that the dark line is the turf with the microclover. You can see that everything trends pretty closely. Here's the data for the Kentucky bluegrass. The microclover did marginally better over time. The impact of minimal amounts of soil moisture can impact the success or failure of the turf under drought conditions. Overall, everything is still clustered together. Here's the data for the tall fescue. We also evaluated the temperature of the plots over a 1-week period. The microclover plots look like they are straddling above and below the non-microclover plots, with the microclover on top and the microclover and plus fertilizer on the bottom. In this data, the lower the temperature, the better. Here's the data for the Kentucky bluegrass. The microclover is running several degrees cooler than the rest of the treatments. When we overlay the data, we can see how the two plots compare. I am not sure that this tells us anything important at this moment in time, but it may with additional data. As part of the grant study, we want to tie the performance data back to the cost of running a sod farm. This is the linchpin of all the work. Being able to show a real tangible benefit tied back to the finances of the sod farm is critical. If the work provides value or cost savings, it is a win for the sod producers. We need additional collaborators who will work with us on the financial aspect by confidentially sharing some of their financial data, so that we can see if microclover can make an impact upon their business. With fertilizer prices steadily rising and water resources over the next 20 years becoming more precious, we want to provide tools to sod producers to manage these inevitable changes. Please contact us if you are willing to partner. Our contact information will be provided on the last slide. The largest component of growing turf is labor and payroll taxes. Additional expenses that we are proposing to impact include fertilizer and pesticide. The majority of labor expenses are in mowing, but by reducing the need to fertilize and apply pesticide, we are also reducing labor required to apply them. Reducing both fertilizer and pesticide application by 50% along with labor required would result in a 5 to 10% cost savings for the sod farm. We will we will still need to account for the costs associated with the microclover seed and its application. Here is a current list of our collaborators. If you would like to participate or support this objective, please contact us and let us know if you would like to support this work by volunteering to help grow a 1/4 acre to an acre plot of microclover and turf, or support our need to economically evaluate the benefits of microclover. You can contact Dave Gardner or John Street at The Ohio State University. Thanks.